Hello, everyone. I hope everybody out there is doing great today. This is Dr. Dax, and we are in week 4, session 2 of your infrastructure hardware class. I had to think about which class I'm in. I'm teaching a couple different classes tonight. Yeah, week 4. So I hope everybody out there is doing well and really keeping up with your deliverable content. Some really good stuff has been flowing through, and some things that had to be corrected with feedback I've been seeing as well. And so at this point in the semester, it's a good time to kind of pause and take a moment to address a couple of things that I see the most often so I can help you guys produce the greatest content that you can possibly make. I think that you guys have tremendous potential and a lot of really good research skills and communication skills. I just want to help you with a couple of tips today before we get into our main content to kind of shake things up a little bit and kind of help you along the way with your content presentations, your paper writing. Just a couple of brief reminders. Now, in week 1, I gave you an overview of our expectations in writing, and I said that I would probably circle back to it. And so that's what we're doing today, so we can be specific. I keep providing some feedback, and I'm hearing consistent things being said by me. And so if I'm repeating myself in the feedback, that means that some stuff needs to be reiterated, and that's totally normal. Don't take this as negative feedback or anything like that. This is all constructive. This is me trying to help everyone really succeed to the best that they can be. And the better you get at writing now, the more it's going to help you as your academic career continues on. So, without further ado, I'm going to go ahead and dig into that, and then we'll hit our main content. So, while we are doing that, I did catch up on grading as of today. So, and that's what inspired some of this material that we're going to go over. And 99% of what I'm seeing is very, very good. I just want to make sure that we can all get on the same page with all of our expectations. We're going to start with a couple of PowerPoint tips. If I can get my share button to work. Let's open that up. All right. So first things first, on the deliverable content, your assignments are divided into writing actual papers, which might be in the form of a consultation paper for a client or just a general information paper to a broad audience. And some of them are presentations, and they're specified like create a slideshow or other similar presentation. And some of them are ambiguous. They could be one way or the other. So let's start with the PowerPoint tips. The stuff I see most often in PowerPoint that I call people out on is, for one thing, for clarity purposes, let's stop putting all the information you want to say about a certain topic on one slide. Break it up over multiple slides if you have to, but if you come up and give a presentation to a group and you want to say everything about a certain subject all at once, your audience's eyes are going to glass over and you're going to lose them right away. Now, some of the stuff that I show on these presentations do have a lot on there because there'll be charts involved or just a list of protocols about a specific item. That's a little bit different because I'm not going to go and read through every line to you, and I don't expect the audience to read everything on the page. I'm just trying to give an overview, and I also provide all of my lecture notes at the end to everyone who wants to um, read them individually, kind of catch up on the minutia. But generally speaking, when I see all this right here, it makes my head hurt. If I have to read a bunch of tiny font to see if you hit every point of the rubric, it makes me crazy. Instead, what we want to do is make sure that you break things down into unique points and use brevity and maybe 3, maybe 4 points, and just kind of hit the basics as you go along. It doesn't have to look like this. I'm just giving you an example, but say, oh, this is much cleaner than this. Do this, not this. Nice and simple. So you're probably wondering, well, I've got to write so much content because the assignment says to provide an overview of this topic and a best practices of this topic and a frequently asked questions of this. And I get that. There's a solution. And that takes us to number 2 here. I want you to use the lecture notes below to flesh out your details. Even if it doesn't say in the instructions to use lecture notes, That's a good habit to get into. So what you're going to want to do is have your few points here on the slide, and down below, that's where your minutia goes. That's where all the detail goes. Those are the things that as a presenter, you'll have, that you can see and read off of as a reference, but your audience doesn't see it. They just see the, 2, 3, 4 points at the top, and you are able to uh, show your knowledge by talking about them with information down below, but don't put it all on the screen. So another thing you want to do, and then I'll move off of PowerPoints, is be consistent throughout. So the tone, the aesthetics, the type of graphics that you use ought to be the same from beginning to end. It shouldn't look highly detailed on one page and then very basic and just a couple of colors on another. Because when you do that, it looks like you cobbled together different resources and then didn't put any thought into making it cohesive and flowing together nice and smoothly. Now, the way you can do that is go into your slide when you're building the PowerPoint and find a point on the page that's not on a text and right click it. And when you right click it, the options will come up like this drop down box you see here where it says layout, reset slide, ruler, and select format background. This is something you can do to spice up your impression and keep it the same throughout. So you can go into format background, and when you do that, you're gonna have an option to change the different fill types. You can do a solid fill or gradient fill, pattern, or picture, or texture. Now, I've used pictures in the past, something like a nice high-tech looking frame, something minimally invasive, not overdoing it with the graphics, because if you put too much on there and cobble it all together, you'll lose your audience just as well as if you had a ton of written content. So a simple solution for me, sometimes I use gradient fill, and it gives you the opportunity to apply to all, and that gives you a nice color from light to dark, and you can do a radial gradient or a linear gradient, and just experiment with different styles. Don't just do a black and white presentation with 20 slides and just boring and flat looking. Spice it up a little bit. That's on the slideshows. Now, the other piece of information I want to share with you guys is a couple of reminders about APA. In the writing in this school, all papers are in APA format. The American Psychological Association has a set of standards that are academically sound and consistent from one university to the next. And you're going to want to be good at this, because if you continue your academic career later and say maybe you become a writer or you want to publish some actual research, before any publishing house will accept it, it needs to be formatted in a way that is standardized, and APA can help you do that. So get good at that. For one thing, APA requires a cover page. About 2/3 of you are turning in papers that don't have a cover page, don't even have your name on it. APA requires a cover page with your title here, and then your name, the school you're in. You don't have to write the department, even though it's supposed to be on there. I'm not that picky. I don't care if you have the class number, but do have the class name if you can, and include my name and the date. And this tells you here on this to make sure that the top is centered, bolded, and title cased. Every major word there is capitalized. Okay, and in the center of the title page, it's centered, double spaced. It's Times New Roman font, size 12. The other thing that is the most frequent mistake that I see in APA, and when I see it, I call it out every time, and a lot of you guys have heard this. Make sure you cite your text, cite your materials in the body of the text as well as at the end. Most people, when they're new to APA, they fill out the reference list at the end, and that's required, of course, but the reference list is not enough. You need your reader to understand what components you attach to what sources. So in the body of the text, when you say something that's paraphrased or cited, make sure as soon as you say it that the last name and the year is available. So at the end of a sentence, you open up parentheses and put whoever wrote it, comma, and the year, if those things are available. Now, if the author's name is not available, maybe it came from a well-known periodical, U.S. News or something, that's fine. That's a secondary choice. Just make sure that there's a citation there in the year, if available. If there's no year, no date at all, you put ND, no date. Just make sure the citation is there so we can attach the fact that you wrote to a source and follow up on it if we need to. So if it's an exact quote, an in-text citation, you will want to use a page number. If it came from a periodical, for example, and it's on page 8, you'd put that there. But we're still doing this format, name and year. Okay. And if there are any questions about that, reach out to me and I will provide you some more APA templates, resources, and any other items that we can use to help you along your way. I want you guys to be consistent, and that's something that is asked for in the rubric. So when we're talking about grammar and writing at the end of the rubric, APA is part of that. It's not just about spelling properly and having good sentence structure. It's also the formats. All right, so let's move on. Week lecture 4, lecture number 2. We are doing a talk tonight about using and configuring storage devices. It's really a continuation of the lecture in lecture 1. So if you haven't seen the first lecture for this week, go back and check that one out and come back here. So this is going to help you with writing deliverables 2 or maybe 3, where you're talking about the pros and cons of a smaller chassis. There are lots of requirements in that about making sure you flesh out your description of the SAN and NAS, so forth. So we're going to talk about some of that here and help you be inspired. So the objectives are pretty simple. You're going to explain common disk storage technologies, and some of them you know about, but some might be a little bit new to you. We're going to talk about backing up data using existing operating system tools, things that you've seen before, and some newer things if you haven't been involved in OSs specifically designed for a server. We're going to explain network storage technologies, and we'll discuss removable disk storage. Most of that's pretty familiar, so we will just kind of breeze through that. We'll describe tape drive technologies. Some of that is a little bit older than some of you are, but we still use that out there. And we will explain storage management tools in different operating systems. But let's first cover disk storage options. What do we mean by disk storage? Well, today, most computers come with some type of disk storage. If they don't, there will at least be slots where you can attach external drives. Not as frequently now do we see new laptops sold with a DVD-ROM drive or CD-ROM, simply because more and more often we're working online with web-based APIs. But we still use removable hard drives and flash drives, and they can be connected through USB, USB 2.0, the micro USB. So when we talk about disk refers to a hard drive, and a disk with a C can refer to the optical mediums. So if there's any confusion there, remember that. The disk with a K refers to the hard drive disk. Disk with a C is like a CD. So remember C, CD, CD-ROM, DVD-ROMs, that kind of thing. And there are different disk storage options. Now, I'm not going to read all these to you, but you can see that the storage measurement is in the kilobit range to the terabyte range, and this is how it breaks down the number of bytes and the number of binary base 2 and base 10 equivalents. So this is a little reference point there for you there. That comes from table 7.1 in your text. And hard drive interfaces, such as the IDE in older computers, the popular interface was the IDE interface. And you might be more familiar with the enhanced IDE or the EIDE. That supports higher transfer speeds and connects up to 4 devices. And you can find them in some of the older PCs. The American National Standard Institute, or ANSI, refers to the IDE standard as the ATA, the Advanced Technology Attachment. The newer high-speed special version of the ATA interface is called the Serial ATA, or SATA, or SATA. Excuse me. The external SATA drive, or the eSATA interface, enables connectivity for an external SATA drive. Pardon me real quick. Still getting past having a dry throat there. So anyway, hard drive interfaces. Okay, so through the eSATA You can connect external SATA drives by plugging into a port or slot interface. And this happens through the PCMCIA and Express card. With LightPeak, this is an emerging technology that is projected to be a contender for the USB peripheral device market, and that uses an optical connection. Small Computer System Interface, or SCSI, is a relatively fast interface that can support up to 8 or 16 devices, depending on which version you have. Now, disks and other SCSI devices are connected together in a daisy chain fashion. Each end of the SCSI cable must be electrically terminated to prevent echoes and ghost signals in the cable. The terminator is an electronic resistor that absorbs the signal. It can be built into the device, such as the disk drive. And advances in SCSI have resulted in different enhancements. Got Ultra SCSI, Ultra Wide, Ultra 2, the Ultra 2 Wide, and the Ultra 3, and so on. The Ultra 640 transfers at a rate of 640 megabits per second, and it uses a 16-bit bus and handles 16 devices and is used for servers and network storage. The serial attached, or SCSI SAS, is a technology that supports up to 16,256 devices and has initial speeds in the gigabit range, 3 to 6 gigs, and is compatible with the SATA interfaces. The typical SCSI configuration looks a little like this. Your SCSI peripheral, like a scanner, can be attached to your drive, such as the DVD or CD-ROM drive, which has an output on the SCSI cable to these peripherals that have the SCSI ribbon cable, and they can terminate in a serial fashion. And this is a card for a host adapter. With hard drive interfaces, we've got different forms. A GUID is the Globally Unique Identifier Partition Table, or GPT. It's a way to partition the disks, and then it allows operating systems to handle large disk formats. Windows System Utility is a way to view the hard drive configuration on your computer, and we'll see a picture of that later. The hard disk failures do happen, so backing up your computer is absolutely essential. Most OSs offer backup utilities that make backing up easier. In fact, it's almost an automated process now. Those utilities are going to be listed on the next slide. Let's take a look at them now. If you're using an older OS like Windows XP, the utility is the Backup and Restore Wizard, and it goes to the System Tools menu in the Accessories folder or from the Control panel. Now, if you're using Windows Server 2003 and in Revision 2, the Backup and Restore Wizard is started from the System Tools menu in the Accessories folder or the Control panel, like with the XP. And Vista and Windows 7 work similarly with Backup and Restore Center, started from the Control panel. If you're using Server 2008 or Revision 2, Windows Server Backup Utility is a feature in Server Manager, and it started from the Disk Management Console. If you are a Unix or Linux user, you'll use the command line to accomplish a lot of that. You could use dump, tar, cpio, and xfs dump commands. And for those of you who are using Mac OS Leopard or Snow Leopard or one of the associated variants there, you can use the Time Machine utility. Now, basic and dynamic disks and hard drive interfaces. So Windows OS has the ability to distinguish between the different disk types. The basic is a physical hard drive that contains the primary and extended partitions, or logical drives that are known as volumes. Dynamic disk contains volumes that can span across multiple disks. If something happens to one disk, corruption or a physical failure, you still got the data packets on the other disks. It's fault tolerance supported. Basically, it implements software or hardware that protects against hardware failures, power interruptions, and lost data by providing redundancy. It's supported by all editions of Windows Server 2003 and up, and some later versions of Windows Desktop. Basic disks can be converted into dynamic disks by using the disk management tool in Windows. SSD, or solid state drive, is a type of storage technology that uses semiconductors for storage. SSDs don't have a mechanical component, so they're considered more stable, but they're also more expensive. It's similar to the technology used in flash drives, but SSDs are larger and they can hold more data. Advantages over traditional hard drives include, like I mentioned, there are no moving parts. It's not a physical drive that you can hear running like the older hard drives. And it's supposedly not sensitive to magnetic disks. I am dubious about that. I try to keep them away from strong magnetic interference. It gives faster access to data, and it's supposed to be more reliable because there are no fragile drive platters. And this lower power requirements because there's no motor. A disadvantage is it's a higher cost than traditional hard disk storage. RAID arrays are the redundant array of inexpensive or independent disks. RAID arrays serve different purposes: increased reliability, increased storage capacity, increased speed, and fault tolerance. Various RAID designs typically are designated from level 0 to level 5, and it can be costly and is primarily used on servers. Now, we've covered RAID before, but this is a nice review that should help you. RAID is implemented as a combination of hardware and software. With the hardware, you're dealing with hard disks that are connected to a controller or multiple controllers. And the software is a controlling system that provides the interface between the OS and the special RAID features. Modern RAID systems offer configuration at the hardware level. It does not need the OS to be configured. And RAID is covered in more detail in Chapter 11. So CD technology, compact discs are polycarbonate plastic discs that have a reflective optical surface and can be read by a laser. And CD-ROM is the read-only memory that uses the technology that is taking the data, pressing it on the disk one time, and if it's read-only, but it could be played many times. Now, CDR is a compact disc recordable. Information can be burned multiple times. And CDRW is compact disc rewritable. You can write to the disk over and over. And CDs store the data on a big spiral instead of on tracks or sectors, like on hard disks. So when a disk is read, a laser light is emitted from the CD-ROM drive head and is reflected off the surface into an optical pickup. The surface is covered with little indentations or pits, and depending on the size of the pits, it returns a 0 or a 1. It's all binary data, but it's translated into useful information. The surface of the CD reflects light during the data read operation. And it should be noted that CDs are very sensitive to scratches and other kinds of damages that can hinder optical readout. The data on the CD can employ any or all of the following recovery methods. Parity recovery is simple error detection, and it typically counts the number of non-zero bits in a string of data and then sets up a parity bit to reflect whether the bits total to an even or an odd number. And error correction codes can replace errors by adding duplicate data or parity data so the missing information can be recovered. Error concealment uses surrounding data to help calculate the approximate data to fill in for the missing data. It's almost using a form of machine learning to extrapolate what it thinks goes in there. And CRCC is cyclic redundancy check code. That uses an algebraic polynomial function to look for an error key and detect and overcome errors. And the Reed-Solomon RS codes use a complex polynomial technique to address data errors. A standard CD can hold 737 megs, and counting for the space for error detection, the true storage capacity is closer to 847 megs. And CDs are rated usually in terms of recording minutes as well as megabytes of data, and they are used for music or audio as well as digital data. And rotational speeds can range from 200 to 500 revolutions per minute, or as high as 72 times that speed. A DVD works a lot like a CD, but the storage capacity is much greater. And DVDs can store information on two sides with up to 2 layers per side. Unlike CDs, they have a second layer that is read by using light that hits the disc at a slightly different angle. And a single layer, one-sided DVD can hold 4.7 gigs of data. A double-sided can hold 8.54 gigs, and a double-sided can hold 17 gigs of data. We don't hear as much about those now, but I wanted to make you aware of it. And recordable and rewritable DVDs are still available. You can get digital video disc recordable, a DVD minus R, or digital video disc plus recordable, which is DVD plus R. And the DVD and CD-ROM drives are normally connected to a computer using a hard disk interface. Most PCs use the SATA, EIDE, or SCSI interface that we described before. And they require different drives than hard disk drives. Most PCs have drivers built into the BIOS system and the boot system. This enables the computers to boot an OS from a CD or DVD. And most PCs can boot an OS directly from the DVD or CD-ROM for initial installation. The Blu-ray drives are different from the others because the data is recorded on top of a polycarbonate layer. This enables the information on the disk to be read with a greater level of accuracy without the problem of disk tilt. Data transfer speed can reach 36 megs per second compared to about 10 megs per second for DVDs. And the current storage capacity is about 50 gigs. It's connected to computers using an SATA interface. And to play a Blu-ray video on a computer, you have to have the video display that is capable of high bandwidth definition content protection, or HDCP. However, like I said earlier, we are transitioning from reliance on discs and DVDs to working online. So thus, most computers now are not even sold with a DVD-ROM. Cloud storage is more frequent than before. Organizations today deal with massive amounts of data. So in dealing with backups and asset recovery, the availability of data are reasons why storage area networks and cloud storage are highly popular. The SANs, or storage area networks, involves a grouping of storage devices that form a private network. Data transfer between servers and storage systems takes place on a fiber channel. Typical speeds for most fiber channels is around 8 gigs per second, and others are under development that reach 16 to 40 gigs per second. The typical network storage and cloud storage SAN storage area network looks a little like this. You've got your storage disks all connected to a switch. The fiber channel switch sends the data to the different servers. This is all part of a local area network. This is a kind of a watered down version, but this is giving you the impression of what a SAN it typically involves. InfiniBand is designed for ultra-fast connectivity in data centers, like linking servers for clustering to act as one powerful server. It emerged as an alternative to fiber channels. In network attached storage, or NAS, it's a way to directly attach storage to the LAN. It works with multiple OSs and allows most clients to access the storage on the network using TCP/IP protocol, the standard network communications protocol. It's different than a SAN. Servers communicate with storage over the main network rather than by separate fiber channels. NAS can use Internet Small Computer System Interface, or ISCSI, for communications. It offers a TCP IP-based communication that enables connectivity with SCSI-based storage arrays. And faster data access than fiber channels is available because data transmission speeds are linked to the actual speed of the network. And because it uses TCP IP, it can be used on LANs, WAN, wide area networks, or over the internet. The disadvantage is that it creates extra network traffic and it stresses the system a little more, and it can lead to network congestion. A typical network storage and cloud storage setup with the NES, the network attached storage, can look like this. The NAS switch and the disk storage can run together concurrently in series. They're all connected to the local area network. So that's why it's able to transmit over the TCP IP rather than relying on fiber channels. The cloud storage is available through the internet through web-based applications, and data may be transferred over the internet or network to the user's computer, or the user can manipulate data on a remote computer via the internet. Anytime that you've collaborated on Teams, for example, you're using network storage and cloud storage, and everybody has access to the same thing as if they're looking at the same, well, they are looking at the same drive. It's just not a local drive. Users' data is available from any location where internet is available, as long as you have the appropriate credentials. And it provides fault tolerance. Examples of the use include YouTube hosting its millions of video files, Google Docs storage, mentioned Microsoft Teams earlier, even though it's not on the slide. And files can be made public or kept private. They can be encrypted, or they can require password protection, or it can require an invite from another existing team member. And removable disks include things like floppy disks, which you don't see as much anymore, although my day job, we do have older systems, legacy equipment that relies on floppy disks for backups on a weekly basis. And some places still use zip disks. They have storage capacities from 1.44 megs on the floppies to 750 megs on a zip disk. And I remember when zip disk was supposed to be the floppy disk killer, but it didn't really happen because of the high cost. So today, users expect removable storage capacities to match hard disk capacities, and they almost do. Some removable hard disks that connect to USB ports can hold over a terabyte of data. The one that I carry around can put a couple of movies on and lots of other files. It's mind-boggling. Another option is a removable SSD. Remember, we talked about solid state drives. They're not mechanical. They're just they're like a larger version of a flash drive. It connects to your computer through a USB port. And other options include LightPeak or eSATA, which we mentioned earlier. And everybody knows about flash drives. We'll just kind of gloss this over. Flash drives are thumb drives that plug into a USB port and don't have any internal moving parts. They're so solid. I've actually had some that you use on a keychain and carry important files with me. In fact, that was my go-to when I was actually in college after I had a computer crash and I lost everything. I was storing everything locally. This is before cloud services were a thing, widespread. And so before I got to doing online backups through Perla and other programs like that, I carried a flash drive. I just would plug in my thumb drive, save everything. And in fact, I set it up to save every few minutes. All right, they don't require additional drivers and are quickly recognized by PNP. They're easy to use, they fit in your pocket, and typical sizes. This is actually outdated, 4, 8, 16, 32, 64 gig. They're in the terabyte range now. They work with all operating systems, and some places might still be using tapes and tape drives. I do actually use them on the older Nortel switching equipment. Tape systems are really good for holding large amounts of data. They're mechanically very sound. They last a long time if they're taken care of. They use magnetic storage to record the data in a sequential order. And they're not perfect. The disadvantage being that to find a file, if it's near the end of the tape, you have to drive through all the other data to get there. And access to data is thus slower than your typical removable hard drive. And it's most popular for long-term storage. With disk drives growing into the terabyte range, tape drive technology is continuing to evolve to try to keep up. And here are some capacity ranges for tapes and tape drives. I'm not going to read all that to you, but that is available in the notes. You'll be able to go over that. DAT drives are digital audio tapes. They use a 4mm tape and a DDS, or digital data storage format. So DDS1 has a capacity of about 2 gigs, or you can compress 4 gigs of data. The current standard is the DDS5, the storage capacity of 36 gigs or 72 gigs compressed. They are backward compatible. You can upgrade to a DDS5 drive and still read the older DDS4 tapes. And they're rated at an archive life of about 10 years, although some places hang on to them longer. And they're still used for audio recordings, but use for data storage is mostly replaced by digital tapes, or digital drives rather. And DLT tapes are digital linear tape. They use a 1/2-inch wide magnetic tape and record data on tracks. They offer high speed search capabilities, and a file can be found in a few seconds to a little over a minute, depending on the location. And it's used in a lot of automated tape backup systems. And SDLT drives are the super digital linear tape, and they use both magnetic and optical recording methods. Laser technology can be more accurate with the right data and put it on the tape to allow for greater density of information. And it can hold up to 2.4 terabytes compressed. And both the DLT and SDLT have an archive life of up to 30 years. AIT drives are advanced intelligent tape. They were first introduced in the late 90s and used mainly in mid-range servers. The tapes have an erasable chip inside the cartridge, and it stores information normally written at the beginning of the tape. And it can fast forward to pinpoint information quickly. And they started out with a capacity of 35 to 90 gigs. Now the SAIT, or Super Advanced Intelligent Tape, has a greater capacity. It's more of the 500 gig to 1.3 terabyte range. And both of the drives can sustain up to 30,000 tape passes and have an archive life of about 30 years, which is crazy. All right, and that's where we're going to stop for now. I hope that this information is interesting to you guys and that it's a helpful resource as you continue on through these deliverables and through your studies. If you have any questions about anything, I want you guys to shoot me a message to dax.bradley@rasmussen.edu. You can also call or text me at 252-458-7176. And that's about it for now. I hope you guys have a safe rest of the week, and I'll see you again on Tuesday as we start out week 5. And keep trucking on those deliverables, and let me know if you need anything at all. All right, Dr. Dax out.